Yes, hello everybody. I will give you a short presentation about synthetic data generation for AI-based automation and quality in the field of quality inspection, but also in the field of object detection. You can use this simulated data. So we will have a short look first. Why should we generate synthetic data? Why do we need it? For AI-based problems or machine vision tasks like object detection or object classification and also quality control, you need problem-specific data sets. And this is always the problem. you need large data sets and you need them problem specific. So it's not helpful if you have a lot of pictures of cats and dogs if you want to detect defects on metal parts, for example. Yes. So you need special data sets, and typically for supervised learning you have to create annotated data, and this is a very time-consuming and manual process, especially if you are not talking only about pictures but also about 3D data sets. If you have to do 3D annotations, it's much more time-consuming and a tedious process. So, and of course, challenges are always the data sets are not balanced. So you have maybe a few pictures from defect number 1, but a lot of pictures from defect number 2. So it is not balanced, and in the end your AI model will not work well. And if the annotations are done by people, yes, you have, of course, the influence of the person who does the annotation. You end up maybe with different kind of annotations. You see it here in our logo. You can do the annotation this way, very close to what you wanted to detect, but you can also put boxes, larger boxes, around the complete logo maybe, and this makes a difference in the end for the AI model. So to overcome these challenges, an approach we use is we simulate training data, yes? And we do this based on virtual 3D scenes. This means we have our objects in the 3D scene, we have its material, we have the camera system, the lighting, and of course the defects on the object. All this is built up in a virtual 3D scene. And then we use physically correct rendering techniques to simulate, and we simulate a light flow from the illumination through the scene to the camera. And what are the advantages here? Of course, we can generate a large amount of data and with minimal manual interaction. Yes, it's more or less an automated process. We can model different types of defects in the necessary numbers, yes? So we get balanced data sets. And we have automatically the detailed annotations. They are delivered for free because we know where the defect is, we put it in, yes? And of course there are not only advantages but also challenges. And of course it is a challenge to do this simulation so that it is close to reality and we have a very small domain gap, yes? And yes, and of course some real data is still needed. In most cases, we end up with a combination of simulated data and real data to receive the best results for an AI-based solution. Yes, so what can we do? First of all, I want to show you a bit on these packages. What can be done in the simulation is also a deformation. If the object is it's not stiff, we can model also deformations with this cage deformation, for example. Yes, we transfer the object in different positions and end up then with a variety of deformations, and we can also simulate the objects falling on a conveyor belt or falling on a table for later on object detection. What you see here is complete simulated data. It's not real data, it's simulated data shown here in the picture and random arranged, and you see also reflections, you see the printing and everything. Yes? So we are able to create a lot of different kind of situations with the random objects and train our AI model for the object detection. Of course, illumination is important, yes, and we have on the one hand, of course, the illumination in our visual inspection system, but on the other hand, maybe illumination from the surroundings, from our environment, where our vision system will be set up then. And here you see different kind of environmental situations which have an effect on our objects. You see here on top an industrial illumination scene, maybe with cool light, yes, and you see the simulated image in this scene. Here we have an outdoor scene where you see also the leaves of the trees which are reflected on the objects. Or we have a very warm environmental situation with warm light, which is also then shown on the images. As I'm afraid a bit on the screen, it's not so optimal as on the computer. But I hope you can see the differences, yes. And we can also put this in our simulation using environmental maps. Yes. Then, of course, what is very important is the material of the object. Depending which kind of material you have, complete other surface structure, you have other reflections, things like that. And we start with only the geometry and a basic material, for example, a metal, yes. And then we do the shading, we modify the surface structure with different kind of maps, diffusion maps, normal maps, roughness maps, to get the final object surface. And of course, we can vary this surface with our shader by putting noise textures on it, low frequency noise, high frequency noise, and combine them also to a resulting noise structure to get different kind of appearance of our object. And of course the defects, this is the reason why we want to simulate, we want to have enough defect images. And for example, we have scratches here on on these washers. These are metal parts, yes, and we can simulate scratches by using these displacement maps. We put there automated scratches in this UV map and put it on our object. So we have different kind of random scratches with different length, different appearance on different positions on our washer. And there are, of course, more defects like dents or notches. And here we can use also 3D operations like Boolean operations to put here those notches or dents in the object, yes. And here you see now a comparison between the real camera images in the upper row and the simulated images, synthetic images from our synthetic data set. And you see there is not a lot of difference you can see. If I hadn't put maybe what is the camera image and what is the synthetic, it would be quite hard to say which one is which one. But you see also, if you look on the upper row, you have a great variance already in the real images. And of course, you need to have all these variants, of course, also in the synthetic data. Otherwise, it won't work in the end. Yes, you see the washers sometimes look quite light and sometimes quite dark with more structure or less structure on the surface. So all what is possible in reality should we also have in the synthetic data. Yes, then we used this synthetic data and trained our neural network. In this case, we used an efficient DET architecture. And yes, to have these 4 classes of defects which we want to detect in our data set. And then we did the training. We did 3 different experiments. On the one hand, we did a training only with real data. Then we did a training only with synthetic data. And then we did a training with mixed data set, yes, and compared the results. So in the real data set, there was only yes, not a lot of images. We had 40 real images for each defect category. In the synthetic data, we had 500 for each defect category. And in the mixed data, we had these 500 synthetic plus the 40 real images. Okay, how did we evaluate the results? We used the intersection over union here. And of course, true positive was if the intersection over union was larger than 0.5. The false positives, the false negatives, you see here. And we calculated precision and recall. So just for visualization, we see here test images with the predictions. The color of the box represents the defect category. So we have 4 different colors for the 4 kind of defects. We have dents, we have bumps, we have notches, and in the right image we have the scratch. Yes. So, and here is the result. So you see, of course, with real data, we get quite good results already, yes. But, for example, especially the class scratch, the recall is not very good, yes. It is only 0.54. With the synthetic data, we receive nearly the same results, but especially for the scratches, we are much better, yes, because we had a larger variety of scratches in our training data. And with the mixed data, there we received the best results, of course. But you see already with synthetic data, we received a very good performance of our AI-based solution. And in the end, one more example from the object detection. So here you see syringes. On the left side, this is a synthetic image of syringes. So we modeled the syringe from two parts. These are transparent objects, yes. So it's not that easy, of course, but you see the transparency in the synthetic image is quite good, and it looks very realistic. And in the background, of course, we have always the 3D model, so we know exactly the position and the geometry of our objects in this image. And on the right hand, you see then the detections in a real camera image from an AI-based object detection, which was only trained on synthetic data again. Yes. So we used the left box situations for the training and received then very good results from the object detection in the real data set. Okay, so just to give you an overview about our work, if you want to see it more in detail or see this application live, you can come to our booth in Hall 10, booth G45. Yes. So thank you very much.
Thank you very much.